let's see how to build a simple to-do list using C# and WPF. So I already have Visual Studio open, and let's create a new project. So File, New, and I choose Project. And of course here I'm going to make sure that I chose C# and it's going to be a desktop application. Here I'm going to choose WPF application, and let's continue. And I'll name my project WPF to do. This looks fine. Let's move on. And I'm going to go with .NET 8, which is the long-term support version. Works fine for me. Let's create the project. And here for the XAML file, I'm going to hide the design view as I never found it too useful. So the first thing I'm going to start with is creating a new class for the to-do item. This is the class that we will use to generate our to-do objects. Each to-do item will be an instance of this class. So let's start with it. So here I'm choosing add and new item, and it's simply going to be to-do. First, I want this class to be a public class. And each object of this class is only going to have two properties. The first is going to be its title, and the second is going to be its status, whether it is completed or incomplete, and I'm just going to call it is done. Now, later on, we're going to bind these properties in our WPF XAML file, and this is why they both have to be properties, actual properties. And not only properties, they have to be public properties. So let me make both of them public. Now, as for the title is going to be a string, and the isDone property is, of course, Boolean. And let me also get rid of all of the unused use. And since I want these two to be properties, I'm going to add to both of them get and set. And just to get rid of this warning, maybe let's give an initial value to this string, even an empty string. Next up, I want to create my Todos file. And Todos is going to be another class that is going to use the to-do class. So this one, what we just created, the to-do class, this one represents a single item, a single task. I now want to have another class that manages all of the to-do items. And this new class that we are about to create is also the one that we will use to bind to the WPF XAML file. So let's create it. It's going to be to-dos. So once again, add new item and to-dos. So this is the plural form. And I want this class to be public. And as I said, I'm going to later bind to some of its properties in my WPF XAML file. And this is why this class has to inherit from iNotifyPropertyChanged. And notice that as soon as I choose this option, a new using was added for system.componentModel. By the way, let me get rid of the rest of them. Now, as you can see, we now got an error. And the reason for the error is that if we inherit from this class, there is a member that our class has to implement. And specifically, if I click here, I can see that I have this option, implement the interface, and it automatically added this event, the property changed event handler. I now want to add a method to my class, and this method is the one that will invoke this event, the event that we just had to add. And this method is going to be public void, and I'm going to call it onPropertyChanged. Now, we are going to use this method whenever we detect a change to any of the properties in this class. And this is what's going to notify the WPF XAML element that a change has happened and they have to update themselves. So since we are going to use things from this class as the data source for WPF, we have to let WPF know whenever changes happen. And this is exactly the role of this function. So as a parameter to this method, I want to know what is the property that just changed. And usually we do it as a string. So I'm just going to call the parameter string property name. And actually this method can be private because we're only going to use it from within this class. And all I want to do in my function is to invoke this event. Do you remember this event? This is exactly what's going to notify the WPF elements that a change was detected and the WPF UI might need to update. So to invoke this event, I'm just going to write here the name of my event, property changed, dot invoke. But it's safer to first make sure that there are any listeners, that anyone is listening to this event. And to do that, I simply add here a question mark, and this will prevent the event from invoking if there are no listeners. And the syntax is as follows. This, and we need this first parameter because this is the context. And the second parameter is new property changed event args. And in the constructor of this class, we need to send the property name. So this is the property that actually changed. And this way, we're letting the user interface know that this is a specific property that changed. And now that I have my infrastructure, I can move on to actually hold the information that I want in this class and the properties that goes along with it. So since we want here a property, and we also want to call this function whenever we detect a change to the property, we usually create a private field for the information, for the data, and a public property that goes with it. So in my case, I want a list of to-dos, a list of these things, And I also have a public property for this list. So I started by creating my private field, which is a list, and I already implemented its get. And all the get does is return the private field. But actually, since we want to keep track of the values in this list in our WPF XAML, a list is not the type of container that we're going to use. If we want to be able to bind to this container, it has to be an observable collection. Lists do not support binding to them in C#, but observable collections do. So this is why I'm going to replace my list with an observable collection. And now let me also add the sec to my property. And it's going to be pretty simple and pretty similar to any other property. So I'm going to update my private field, which is all to do, and it's going to be equal to value. But then on top of that, I have to call my function, my onPropertyChanged function, because this is what's going to invoke my event so that the interface can be notified and update. And this is why here I'm going to add a call to onPropertyChanged. And as a parameter, we need to pass the name of the property that just changed. In our case, it is the all-to-dos property. So I'm going to write here name of, and then the property itself, which is all-to-dos. Now, since this class has the properties that I want to bind to in my user interface, this is going to be my content. So let's go to the code of our main file, and this can be found here. In main window, I'm going to open the C# file. And in my main window class, I want to create a reference to a Todos object. In my constructor, I'm going to initialize my reference as an actual object. So Todos is going to be equal to an actual object. And now I'm going to use this object as my data context. So data context is going to be equal to Todos. And this line is what's going to allow the WPF XAML elements to bind to the properties that we define in this class. Now it's time to go to the XAML file itself. And to show the elements of my observable collection, I'm going to use an items control. So here I'm going to add my items control. Then we need to specify what we want it to bind to. So as you probably remember, our data context is an object of this class, of the Todos class. And this is why here my item source is going to be the property containing the observable collection, which is exactly this, all Todos. So here I'm writing binding, and then the name of the property, all Todos in my case. And let me also add a bit of padding here. We now need to show the elements within the observable collection. This can be done using items control.item template. And we need to have a data template control. And here we're going to have access to an actual element, one specific element from within the observable collection. Moreover, we're going to be able to access the public properties of this element. So let's start by creating here a text block, and let's think about the text that we want to show in this text block. So text is once again going to be equal to binding, and what are we going to bind it to? So as I said, here we have access to one specific element from within the observable collection. And within our observable collection, we have, of course, to-do objects. So let's take another look at our to-do class. And here we can see that we have two public properties, the title and is. So I'm going to choose, of course, the title. So back in the XAML file, I'm simply going to write here title. Now, if we want to be able to see anything when we are starting our program, we should probably populate our observable collection. So maybe we should go back to our Todos class, and let's create here a constructor so we can initialize this. We can initialize our collection. So here I'm going to create my constructor, and let's initialize all Todos, which is our collection. And I'm going to actually populate it with two to-do items, just so we can see them when we are starting the application. So I set the title for the first one to take out the trash, and the title for the second one to feed the dog. Let's start our program, and indeed we can see here the two items that we defined in our constructor. Let's now go back to our XAML file, and I want for each of the elements to also have a checkbox in addition to its title. This is why inside my data template, I'm going to have a, and now in addition to my text block, I'm also going to add my checkbox. Next, we want to set its isChecked property. And where are we going to get this value from? So once again, we're going to use bind, of course. And since here we are talking about one specific to-do element, we can use the isDone public property. So here the binding is going to be to isDone. Now I want the checkbox to be to the side of the text block. And this is why the orientation of the stack panel probably needs to be horizontal. And let me also add a bit of styling here, just so it looks a tiny bit better. And let's run our program again. And now we can also see a checkbox to the left of each of the tasks. If in the Todos constructor, I initialize the isDone of the second one, for example, to true, and I start my program this way, we can see that the second one starts as next. I want to allow the user to add new tasks. So let's get back to our XAML file, and I want to have the section that lets the user add a new one at the button. And since we are using a grid layout, I'm going to have two different rows. One for the main content that shows the current tasks, and another row for the new tasks that the user can add. So here, I added the row definitions, and I now have two rows. So the bottom row will use exactly as much as it needs, and the top row will use whatever left. So maybe here I can first add a title saying daily tasks, and I'll just do it in a label. But since I want all of this to be the first row of our grid, we should probably use some kind of container for both the label and the items control. So let's use a stack panel for both of them. And the orientation of this stack panel is of course going to be vertical. And let's also add a bit of padding for everything within this stack panel. So I'm going to wrap it in a border element. And now I can add padding to this border. And this is going to be the first row in our grid. So here I'm going to define grid.row equals 0. And now we are ready to move on to the stack panel that will allow the users to add new to-dos. So down here, let's add a new stack panel whose grid.row equals 1. And all I want here is a text box for the user to type in the new task and a button to add. Let's put them side by side so the orientation of the stack panel will be horizontal. And let me also add a bit of styling. And let's say that the text on the button will be add to do. And now we want to do something whenever the user clicks on this button. Whenever they actually want to add the new item they typed in, we need to do something. And this is why here I'm going to connect a function to the click event. And this is the click event is going to be connected to a function to which I'll call add to do button clicked. And now to actually go ahead and create this function, I'm just going to press on F12. And it took us to the code behind C# file of the XAML file. And here we can implement our function. And here I'm going to create a new to-do object. And now we would like to initialize its title property, right? Because here we can access the title. But how can we know the title that the user typed in? This is why here in the XAML itself, I'm going to give a name to this text box. And I call it new to-do text box. So X name is going to be new to-do text. And now back here, I'm just going to be able to access it. So new to-do text box. And this is the text box element, so I want to access its text. And now I want to update my to-dos container. So here it is, to-do. And this is an object of the to-dos class. So here we have our observable collection. So if I scroll down here, I can see it over here. So we can access it using the all to-dos property. So here it's going to be to-dos dot all to-do. And to add a new element, I'm just going to add. And of course, we want to add the element we just created here. So to-do. And as you might remember here, whenever we update this container, we also call onPropertyChanged. And this is what's going to let the user interface know that there has been a change. So the element that displays this property, which is in our case the item control, needs to be redrawn. So let's start our program. So we can see here the two tasks that we are starting with, and now I can add a new one. For example, eat lunch. Then I can add it. And we can see that it was indeed added to our list.